Well, space. How on earth would you smell it? Well, the way you smell it is you're an astronaut, you've gone out for a spacewalk and you've come back into the airlock, you've closed the airlock behind you and you've put air back inside your airlock and you've taken your helmet off and you go, and it's that when you're smelling space. And lots of different astronauts report different smells. Gunpowder smell, hot metal, and some even smell a burnt almond cookie. So depends what your nose is like, but that's the kind of smell that you have.
Well, you have to be very, very careful when you go to the toilets in space, because if you've seen what happens on TV for astronauts, they're usually floating around in their spacecraft. So first of all, you find the special toilets they have in the spacecraft. You have to put your feet in the foot straps that hold you there to stop you floating away. And then you rest up against the toilet, which is probably very similar to the toilets you sit on in your toilets at school. But these toilets have a vacuum acting on them, a bit like a vacuum cleaner, and they suck you onto the seat to make sure, again, you can't float off, and when you go to the toilet, everything gets sucked away. So it's all very well planned, but you still have to be very careful.
Ooh, how do astronauts drive their spacecraft? Well, you can't use wheels, you can't use oars, you can't use sails. What you've got to use is bursts of gas. That whooshing has just moved me slightly. So we have little jets positioned around the spacecraft, and the astronaut can move a little joystick and it makes the jets move that way, and the spacecraft moves this way, jet goes that way, spacecraft moves this way. Now, most of it is controlled by computers now, but we still have pilots aboard spacecraft just in case something goes wrong and someone needs to have a go on the joystick to make sure we get home safely.
Well, in recent years, we've got some very sophisticated telescopes, which can now detect, sometimes directly, but mostly indirectly, whether there are planets going around other stars. It's really only in the past 20 years we've got that understanding. And it does appear that virtually every star that we look at and can get some measurable results from appear to have planets going around them. There are exceptions. If maybe the stars, and there are many stars which are multiple star systems, maybe there's 2 or 3 stars going around each other, they're a bit less likely to have planets going around them, but there still have been examples found where planets are going around these groups. But certainly every single star, like our sun is a single star on its own, these new techniques have found that there are solar systems going around them. So when you look up at the night sky tonight, then most of those dots up there should have planets going around them.
Okay, we want to cook in space. The problem is gravity gets in the way of a lot of the things that we do when we cook in our kitchens. So the only thing that actually is going to work if we were to take up into space is your microwave oven. So what most astronauts actually have up in space is rehydrated food. We've taken all of the water out of it, and so when it's up in space, they inject the water back in hot water, shake it up with the food, and there, you open it up and your meal is ready. The easiest way is just to look up and enjoy the night sky. Enjoy the moon, enjoy the planets, the constellations, groups of stars and their associations. And you can help yourself out by getting a telescope or a pair of binoculars to really become a proper amateur astronomer. But maybe you want to do it for the rest of your life. And to do that, you're going to need a few qualifications. And for GCSEs, you need to concentrate on maths and science. These are very important aspects of becoming an astronomer. You then can go on to do A-levels. Any of the sciences and mathematics are very good. And then move on, go to university. You can study astronomy, astrophysics, cosmology, or you could study one of the natural sciences. And then you can take that into a career in astronomy. It doesn't actually need to be limited there. You could do engineering and you could be building spacecraft to become part of the astronomy and astrophysics future.
if another planet came too close to the Earth, it would probably depend on how big it was. If it's a small planet, a small moon, an asteroid, and there are lots of these floating around, the Earth's strong gravity would probably pull it apart. The closer it got, the more chance there would be of it being pulled apart. People think that's what happened to cause Saturn's rings. You might know that the big planet Saturn, a long way from us, has got these famous rings, but people think millions of years ago, an icy moon got very close to Saturn, and again, Saturn there pulled it apart, and that's what caused these rings to form around it. So maybe we would get very small rings forming around our planet if a small planet or asteroid got close to us. However, if a really big planet got close to us, then the reverse would happen. A big planet would rip us apart. Fortunately, we know that all the big planets in our solar system are in very stable orbits. Planets like Jupiter and Saturn have been following the same path for billions of years. So fortunately, there's very little chance of a big planet getting close to us. But maybe a small icy moon will get close to us one day and we might get some rings, but that's speculation.
Okay, the biggest star that we've discovered so far is called UY Scuti, and it's a colossal star. It's a red hypergiant, and it's about 9,500 light years away in the constellation of Scutum, and it's huge. We estimate its radius at 1.18 billion kilometers. To put that in perspective, if it was at the center of the solar system, its outer shell would be beyond the orbit of Jupiter. So it's huge. As to the question, will we ever go to another galaxy? Probably, but at the moment, our technology is obviously only capable of sending us around the solar system. The nearest star is 4.3 light years away, so even that's not something we can currently do. The nearest galaxy, Andromeda, is 2.5 million light years away. I imagine that we will go there someday, but we also need to factor in how much energy it would cost to get there. So let's hope for the future. One day maybe, but not soon.
So stars are created by forming from lots of gas in outer space, and gradually the gravity and formation of clumps of matter coming closer and closer together, and as they get more and more together, they form into a great big clump of gas, and with the pressures of those gas, it's converted into energy into heat and light, and it continues to burn, and generally it's from hydrogen into helium. And that's how the energy is transferred to what we see as a star.
Well, the short answer is people don't really know. In fact, that's a good answer to give sometimes by scientists. If you really don't know, you should say you don't know. But there's good reasons to think there might be something there, which people call dark matter. If you look at how the stars in galaxies move, and if you look how groups of galaxies move around, you can work out how much matter there should be in these galaxies or groups of galaxies. But when you compare that sum with the number of stars you count in these galaxies or groups of galaxies, there's a big difference. Sometimes it looks like there's only 5% or 10% of the stars you need to cause the movements of those galaxies in those galaxies and those groups of galaxies. So that difference is what people call dark matter. They think there probably is some matter there, which we can't easily see, and that's on top of all the stars there, but we don't really know, so we call it dark matter.
Okay, so the Greeks and the Romans saw patterns in the sky, which they referred to as constellations and gave them names. The word constellation comes from the Latin word constellatio, or constellatio, which can be translated as set of stars. Itself is made up of two words, again Latin. The word con, which is Latin for together or with, and stellare, Latin for to shine or to gleam. So constellations shine together.
what would happen if the sun exploded? Well, obviously it sounds like a very dramatic event, but astronomers have got a lot of knowledge about the sorts of stars that do explode. Usually, from what they see from all their observations over the many decades that they've been looking at this, they see that the stars that do explode are usually much bigger than our sun. Or maybe they're stars in pairs going around each other. Stars in that combination can sometimes explode. So there's plenty of good reasons to think that our star is not the sort of star, our sun is not the sort of star that will explode. It's just a bit too small.
That's a good question. What is the difference between a black hole and a white hole? Well, first of all, I've got to start with, we don't know that either of them actually exists. We've got some evidence that a black hole exists. We've seen at the centre of galaxies stars whizzing around in really weird ways, and the only way we can really explain that is something really small and with lots and lots of weight behind it, lots of mass behind it, is right in the centre. So that's our evidence for black holes. But a white hole, that's kind of the opposite. So if a black hole is got so much mass, so much gravity that things are drawn into it and they circle around and they eventually end up inside the black hole. What's a white hole? Well, theoretically, it's the opposite. Instead of light going in and matter going in, it's a splurge of stuff coming out. We've got light coming out, we've got matter coming out. The thing is, we look across galaxies and across the universe, and we think we would see these, and we haven't seen one yet. So, we're pretty sure we've got black holes, but we're not sure about white holes. But the difference, black holes stuff goes in, white holes stuff comes out.
Okay, if the Earth was suddenly and systematically cut in half, the consequences would be catastrophic. So let's explore this hypothetical scenario. Depending on the method used for the slicing, the process could be slow and painful or short and deadly. If done through drilling, piercing through the top layer of the Earth's crust would have unfathomably awful implications. As the planet is being hacksawed in half, rivers and oceans would drain, causing drought and an invasion of salt water that would poison fields and plant life. Earthquakes would erupt worldwide as tectonic plates are severed and shifted. Intense geomagnetic disturbances, earthquakes, hurricanes, and other natural disasters would overload electrical grids, so mass power outages would occur. The Earth would be left fractured, with two halves spiraling into the vacuum of space. Initially, survival would be possible, but the transformation would take hundreds of years and probably cost billions of lives in this entirely hypothetical scenario.
Planets are usually formed from an accretion disk, which is formed around a newly created star. So you've got this great big disk of material gradually cooling down and material forming by gravity and bumping into each other. And as they get bigger and bigger, more and more are attracted to each other with the force of gravity until they manage to form larger and larger spheres. And as the dissipation of the accretion disk disappears, we'll find that there are several planets formed around this sun.
Phobos is one of Mars's two moons, and it's really close to Mars. Its orbit is really close. It's only just shy of 6 miles away. So let's explore a little bit about Phobos. Phobos is small, it's only about 16 miles wide, and it's tidally locked to Mars, which means it always shows the same face to the planet. This is due to gravitational forces between the moon and the planet, and it's the same for the Earth and the moon. Phobos orbits Mars 3 times a day, and no other moon discovered so far in the solar system is closer to the surface of the planet it orbits. We don't really know why Phobos is there, how it formed, where it came from. There are a few theories, but we do know that Phobos' orbit is getting closer and closer to Mars as time goes by. So it would have been further out at some point. We've just caught it at a time when it's only 6 miles away. It's nearing Mars at a rate of about 6 feet every 100 years, which, if you do the maths, means that it will crash into Mars in 50 million years.